Hi, welcome to the Applied Color Science webinar series, Elements of Digital Cameras. My name is Matt Whalen. In this segment, I'll be looking at how an electronic rolling shutter works, how it affects the image capture process, and I'll give you some tips on how to minimize rolling shutter artifacts. The best way to approach this topic is to show you an example of rolling shutter in action. Take a look at this video clip. Do you notice anything unusual about the golf club? If you've ever swung a golf club, you'll recognize that this club is bending in a way that is not physically possible. So what's going on here? The answer lies in the way that an image sensor captures an image. This diagram illustrates how an electronic rolling shutter can be used to capture an image. Each colored square represents a single pixel of the imaging array. Image capture starts when a reset-release signal is applied consecutively to each row of pixels in the array, going from the bottom to the top. After a fixed time interval, a second signal, the read signal, is applied, and the voltage value at each pixel in a row is read out. The exposure time is defined as the time interval between the reset-release signal and the read signal. In this way, an electronic exposure window rolls over the image sensor as shown in the animation. So now that we know how a rolling shutter works, how does that explain the way the golf club is bending in this picture? The answer is that even though a digital video camera captures many frames per second, in this case 60, it still takes a finite amount of time for the electronic shutter signals to cover the entire imaging array. So if a video scene contains objects that move very fast across the field of view, the position of those objects may change before the rolling shutter has finished scanning a frame. In the example of the swinging golf club, when the rolling shutter exposure starts, the club is in the center of the image as shown in the highlighted area. By the time the shutter has gotten to the bottom of the imaging area, the club has already moved to the right of the picture. Now let's talk about ways we can minimize these artifacts. These generally fall into two categories: scene selection and camera, or more specifically, image sensor selection. If you're working with a camera or image sensor that uses rolling shutter exposure, it's a good idea to avoid scenes that include fast motion across the field of view. Unfortunately, for areas like sports photography, that's almost impossible. Here's a little trick I've used to at least make rolling shutter artifacts look a bit more realistic. Take a look at the same swinging golf club video, but with one difference. I think you'll agree that this sequence looks a lot more natural than the first. What's the difference? In this sequence, the electronic shutter rolls from the bottom of the image to the top. Because of that, the club is bending in a way that appears more natural, although a bit exaggerated. How did I get the shutter to roll up instead of down? I flipped the camera upside down. This brings up an important point. If you can experiment a bit with a rolling shutter camera and figure out which way the shutter exposes, then you may be able to orient the camera to reduce the unwanted rolling shutter effects. I mentioned before that another way to get around rolling shutter artifacts is by proper choice of a camera, or actually the image sensor in a camera. Turns out that image sensor designers have developed another way to expose and read out images. This is known as global reset or global shutter. With this technique, instead of having an electronic exposure window roll over the image area, all of the pixels in the array are reset simultaneously, as shown in this slide. As a result, all of the pixels see the scene at the same time, which in theory removes any lag between the bottom of the image and the top. An example of a global shutter image is shown here in combination with a strobe flash. These kinds of pictures aren't possible using a rolling shutter imager. So if rolling shutter artifacts are not acceptable for the types of action shots you will be capturing, make sure you use a camera with a global shutter image sensor. I hope you found this webinar on rolling shutter image artifacts both helpful and instructive. Make sure you check the Applied Color Science website for details on upcoming imaging webinars.